Hello friends, so let us solve a problem on sampling distribution of mean. Suppose you have a population having 4 members with values 10, 20, 30 and 40. So we have to assume that there is a population consisting of 4 members. So this is the member of the population. So we have 4 numbers 10, 20, 30 and 40. If you take all conceivable samples of size 2 with replacement, so if we take sample of size 2 with replacement, so this with replacement technique of sampling we have discussed in the previous lecture. So if we take samples with replacement of size 2 of all conceivable possibilities, so all different possibilities of samples if we take of size 2, then what we have to find from those samples is we have to determine the frequency distribution. So we have to first develop the frequency distribution of mean, find the mean and standard deviation of the distribution. So we have to also determine the mean and standard deviation of the distribution, which is nothing but your standard error. So we have to determine the mean and standard deviation. And in the last question, what we have to find out? We have to find population mean. So we have to find out the population means, that is mean of this population consisting of 4 members. And we have to show that population mean is equal to the mean of the sampling distribution. So these are the 3 questions which we have to solve now. So let us solve these questions. So to proceed with first bit or the first question, what is the frequency distribution of the sample mean? So we have to develop the sampling distribution of mean. So how we have to proceed? We have to first take all possible conceivable samples with the replacement. So we have different possible samples. So what all possibilities of sample we will get? So we can get the possibility that it is 10 and 20. So this is the first sample. So as it is already mentioned in the question that the size of the sample should be 2. So we have to take the sample with only 2 numbers. Okay. So first sample is 1020, second sample is 1030, third sample is 1040, then next sample is 2030, then 2040, then we have 3040, then we also have the possibility that we will select 10 first, and again after keeping this 10 value back into the population, there is a possibility that it might get selected again. So we have possibility to get number 1010, then similarly we have possibility of getting 2020, then similarly 3030 and 4040. So it's a possibility that we can get these type of different combination. And there is also possibility that when we do the selection of 1020, 10 is selected first and 20 is selected later. There is also a chance that 20 might get selected first and 10 might get selected later. So that is also the probability. Again, for this case also, it can be 30-10, then 40-10, then 30-20, then 40-20, then 40-30. So these are the different possible samples that we might get. So now let us find out the mean for these possible samples. So the mean or the sample mean for these possible samples. So it will be, for this it is 15, that is 10 plus 20 divided by 2, it is 15. For next it is 20, for next it is 25. Now again for 20 plus 30 divided by 2, it is 50 divided by 2, again we will get 25. Then next it is 30, next 40 plus 30, 70 divided by 2, 35. Then next 10, it is 10, 20, 30, then 40. So now because these are 2 different samples, so we have frequency also. So frequency is 2 here. Now for 20 again it is 2. For 25 also 2, 25 also 2, 30 also 2, then this also 2, then for this 1, 1, 1 and 1. So here bracket represents the frequency. So in this way we'll get all the different possible samples with their sample mean. So now let us develop the frequency distribution of mean from this data. So to develop the frequency distribution from this data, what we have to do, we have to list out all different means. So we have sample mean and its frequency. So what all possible mean values we have got? So we have got mean values. So these mean values are 10, we have got 10, then we will write it in increasing order. So 10 we have got, 15 we have got, then 20 we have got, so 15 is here. So likewise we'll list out all the different sample means. So 15, 20, 25 we have, then 30 we have, then 35 we have, 35 we have, then 40 we have. So these are the different mean values: 10, 15, 20, 25, then 30, 35 and 40. So these are different mean values. Now list out the frequencies of these respective means. So what are these frequencies? So for 10 it is 1. So 10 is repeated only once, so we have frequency 1. So for 15 it is 2. For 20 it is 2, then 3. We have 3 frequencies for 20. Then for 25 it is 2 plus 2, 4. So for 25 it is 4. Now for 30 it is 2 plus 1, 3. 35, 2. 35, 2. Then 40, only 1. So in this way we can find out the frequency distribution. We have sample mean and their corresponding frequency. So we have developed the frequency distribution of mean now. So now our second question or second bit asks us to find out the mean and standard deviation of the distribution. So for this distribution, so for this data we have to find out the mean as well as the standard deviation. So if we take these mean values as individual data, so we can easily find out the mean as well as the standard deviation for this information. So the formula for determining mean is, we will designate the mean for sampling distribution of mean as x bar SDM. So it is equal to summation of f into x divided by summation of f. So these are nothing but the mean values x bar, mean x, SDM. So we can determine mean for this. So in the previous lecture I have explained how to determine the mean for this kind of information where we have x values and f values. So if we do the calculation, we will get the answer for this as 400 divided by 16. So this is nothing but total number of observations, summation of f is equals to 16. So we sum it, we will get 16 here. So it is equals to 25. So the mean of the sampling distribution of mean is 25. So next question. So in the similar question, same question, we have to determine the standard deviation also. So standard deviation for sampling distribution of mean can be determined by the formula. So normal formula for standard deviation is under root of summation of x minus x bar whole square into f divided by summation of f. So this is the general formula for determining the mean. So we'll determine the mean for this sampling distribution of mean. For this data we'll apply this formula and determine the standard deviation. So standard deviation will be equal to under root of x minus x bar into x minus x bar whole square into s. So x is, will take these x value as these individual values, and x bar as x bar SDM. So this x bar SDM will be taken as this x bar, this value. So after putting the respective values, so what we are going to get? So we'll get 10 minus, so this 10 value minus 25 whole square multiplied by frequency. So how much is the frequency? Frequency is 1. So frequency is only 1 here. So multiplied by 1 plus x minus x bar. So 15 minus 25. So 15 minus 25 whole square. Frequency is 2. So multiplied by 2. Then plus 20 minus 25. So 20 minus 25 whole square. Frequency is 3. So plus next is 25. So 25 minus 25. 25 minus 25 whole square. Frequency is 4. Plus 30. So 30 minus 25 whole square multiplied by 3. So multiplied by 3. Then again we will add 35 minus 25 whole square. So 35 minus 25 whole square multiplied by frequency is 2. Multiplied by 2. Plus last 40 minus 25. 40 minus 25 whole square. Frequency is 1. So now this whole is divided by sum of the frequencies. So it is 16. So it will be 16. So after solving this, we are going to get under root of 1000 divided by 16, which is nothing but under root of 62.5, which will came out to be 7.9. So this is the standard deviation. So this is nothing but your standard deviation of sampling distribution of mean. So this is standard deviation of SDM. So we have got the mean as well as the standard deviation. So this is mean and this is standard deviation of sampling distribution of mean. So next question. So our next question says that we have to also find out the population mean, and we have to prove that population mean is equals to the sampling distribution of mean. So let us solve that part also.